Missouri Department of Transportation. And John, he's been a construction materials engineer with the Missouri DOT for 21 years. Prior to that, he was with the FHWA, and he's on some pretty important committees over at TRB and AASHTO, including Concrete Pavement Construction and Rehabilitation Committee, AKC 50, Interlayer Systems to Control Reflective Cracking Subcommittee Chair on AFD 30-1 for TRB, and then on a number of committees over at AASHTO as well. So we're very fortunate to have John with us here today. He's also a civil engineer in Missouri and has an education from University of Illinois in Champaign or Urbana. So John, and there you are. I see your presentation. Everything's looking good. I hope your sound as well is on tune here. So I'm going to duck out and turn this over to you. We're going to be focused on concrete overlays, which is really kind of an emerging thing out here in the West. I think we've fallen behind a little bit the rest of the country in the use of concrete overlays, but with all the talk of sustainability and economic, focus on economics, we're finding it to be an excellent tool to have in the toolbox. For some of these projects out there, it's really a great option. And I'm looking forward to hearing your insight on concrete overlays. So I'm going to turn it over to you.
Okay, thanks, Charles. Is my sound good?
Sounds great. Yep.
All right. Okay, I'll get started. All right. Well, thank you. It's a pleasure to be presenting here. What I'm basically going to do is kind of talk about our experience with concrete overlays, which I think at this point is kind of, I'd say, relatively extensive. We haven't done as many as a state like Iowa, but I'd say we're probably up there, maybe in the top 5 or 6 states as far as the number and history we have with concrete overlays. And just to go back, and the only reason I know this is because I came across an old research document years ago, like it was done 40 years ago, doing an inventory of concrete overlays in Missouri. And I don't know how they found this out, but they actually went back to the 1930s, which is pretty surprising that we'd be trying this back at that period. A little under 24 projects over a 40-year period. And as far as I guess they were meant to be unbonded overlays. And as far as the bond breaker materials, it was like gravel. I mean, just whatever loose material they could come up with, I guess. But most of those projects have either been buried or abandoned. And so I really can't go back and look at any of them. There's a couple exceptions. This is one. I went out and cored this. I think it was almost 20 years ago. And at that point in time, this was already a 40-year-old concrete overlay. It was in a small town, but it was near an interstate interchange. And it did surprisingly well. And you can kind of see that picture there of the core on the lower right side. It was debonded between the 2 lifts. I could not tell if it was purposely debonded or if they had attempted to bond it, just debonded over time. And because there's no material or any evidence of material used to create the bond breaker. But anyway, it was holding up okay. I mean, I think this was overlaid about 10 years ago, but still went about 50 years without any type of rehab. And just for grins, I'm going to talk a little bit about this because it's still out there, but this isn't going to be the focus of my presentation. On I-70 in central Missouri, we had an older jointly reinforced concrete pavement. It had been overlaid about nearly 20 years after it was constructed in the early 80s when the overlay went down. And then in 92, we constructed a unbonded overlay, an 11-inch thick unbonded jointly reinforced concrete pavement. So in other words, we're using the same design as the original concrete pavement. Our jointly reinforced concrete pavements, and by the way, JRCPs in general have gone the way of the dinosaur, I think for good reason too, but us and a number of other states, this was pretty much the only way to construct concrete pavements for about a 30-year period. in our case, 61.5 foot joint spacing. And so we did the overlay with the same length joint spacing as well. And this is, I'm glad I was able to find these pictures because it's nice to go back and sometimes take a look at older construction. And the way it was basically done in kind of a 2-lift operation. They pulled the spreader across to lay down about the first 7 or 8 inches. And then there was kind of a shuttle buggy vehicle in the middle between the spreader and the slip-form paver that had these sheets of the wire mesh, and then they just manually unload the mesh. And then you don't see it in the picture here, but behind the mesh vehicle was the slip-form paver coming by with the final 3 to 4 inches, and then it would vibrate everything. You can tell from the high precision technique here for placing the mesh that it's small wonder that we would have high steel issues. You can tell obviously from curling there on the edges that once you place the final lift of concrete and you vibrate it, and who knows how the mesh is floating from the vibration afterwards, that you could wind up being closer to the surface than you want to. And this was really kind of, unfortunately, kind of a bad legacy with the jointed reinforced concrete pavements. Although structurally, it's great. I mean, it's like a tank. 11 inches of concrete is basically an interstate pavement by itself, but then you're placing it on an old concrete pavement. It had tied shoulders, and this is just the recent IRI average was 43.6. So this is really a smooth pavement. Haven't had to do anything to it, except in these locations where you see here we're doing some partial depth repairs. This is where the high steel was a problem. And, to me, I consider the mesh popping up in places to be really a cosmetic. It's a nuisance, don't get me wrong, but it can be handled through partial depth repairs. So really no what I call major structural failures with this overlay. And this is a great way to build overlays, not necessarily the 61-foot joint spacing, but, coming in with something this thick. The thing is, though, is we're not building concrete overlays this thick routinely. If we're going to build something this thick, we might as well just build a whole new pavement at that point. But it's no surprise that after almost 30 years, this is still holding up well. Now, the focus of what I want to talk about, though, really is what we've constructed over the past 20 years. The main portion of this is going to be the thicker unbonded concrete overlays. In fact, at this point in time, they cover about 5% of all our interstate centerline miles. So it's a pretty good, significant portion of them. They're all a jointed plain concrete design. So we build our new fold-up pavements as jointed plain concrete with 15-foot joint spacing, and we also do with these thicker unbonded overlays as well. And the design thickness, just about for all of them, was intended to be 8 inches. We also have done smaller unbonded overlays, which range in thickness from 5 to 6 inches and are sawed into smaller panels, typically 6 by 6 or maybe 6 by 7 if we're doing a widened slab design extending over into the shoulder a little bit. And then also we have done some bonded concrete overlays on asphalt, mostly at intersections. So these are smaller projects. All of them were 4 inches thick by design, had the 4x4 sawed joint spacing. They all had polypropylene or polyolefin fibers in there for reinforcement. And we also did, I'm not really going to talk too much about these, but we have attempted concrete on concrete overlays as well, just a couple of those. And this map here kind of shows you how these projects are distributed around our state. Pretty good cross section. You can see there's quite a few on I-44, along the I-35 corridor. I'm not, again, these are the newer overlays. I'm not even showing you the one on I-70 that I just talked about. We also did one experimentally up on I-29 that I'm not going to get into, but the ones that are part of our current inventory, still functioning, performing, fairly well or very well, is what I want to talk about. And of all these projects, I want to focus on these 5 here for a little bit. Each of these projects has some significance to make them stand out a little more than the others. And we'll talk about the I-44 one. This was our first 8-inch unbonded overlay that we did. And we built this 20 years ago. And it's in a, well, pretty much all of I-44 for us is high volume traffic. So it really is put through the ringer when you construct something on 44. And again, the 15-foot joint space. And in this case here, we're putting it on existing concrete pavement. So we had to create a bond breaker. And so we placed 1 inch of asphalt. And in this situation too, we also had tight shoulders, tight concrete shoulders. These are recent pictures I took, trying to recall if it was 17. No, I'm pretty sure this is 2018. I took these shots. So overall, doing real well. The recent IRI numbers we had was about 50 inches per mile, pretty smooth. We've done a survey of them as part of a research project that I'll get to at the end of this presentation, talk a little bit about that. And only 0.6% of the slabs had any type of cracking. And when I talk about any future discussion I have about cracked slabs, keep in mind it's any crack. So a lot of times you could have a relatively minor hairline crack that you don't have to run out there and replace the slab. I mean, it could stay that way for years before it gets worse, if it gets worse. The total easels over the 20-year period has been about 27 million. We did have some polishing of the limestone coarse aggregate. So we grooved this in 2010, but again, that's a cosmetic issue, not a structural problem. The next project I want to talk about is US 60. This is a 2-lane route. It actually connects, it's at Neosho in southwest Missouri. And the western terminus of this project was actually the interchange with I-49. So we have a lot of truck traffic coming off there. And for a relatively small town, the 20-year traffic was 5 to 6 million easels, which is, I think, relatively significant for a road of this type. The existing pavement was asphalt, and it had a lot of rutting and shoving. And so they were trying to come up with a different solution to just coming back with another asphalt overlay that was going to rut within a couple of years. So built 6,000 feet, over a mile, and this is by far our largest bonded concrete overlay on asphalt, in addition to being our oldest one as well. It's at 22 years now. And did the standard surface prep, which is cold milling the asphalt, so you're getting some good 3D texture with the striations from the milling teeth, and then air blasting it, make sure there's no loose material, and then just basically placing the 4-inch overlay with the fibers, no steel in this, it's too thin for steel, sawing them into 4x4 panels. This is a picture I took within the last 3 years, yeah, and you can see it's really doing pretty well overall. Great performance on this. Now the exceptions, and I'll always provide full disclosure. I'll show you the warts, as well as the great things going on with these overlays. Typically, where you have any type of situation where you can have trapped water. In this case here, you can kind of tell there's a change in the color texture from one side to the other. We had a header, it had a construction joint here, so they had the header. And so there was an easier place for water to infiltrate. And there are a couple of construction joints within the 6,000 feet because it was paved over, I think, about 3 or 4 day period. And at almost every one of those construction joints, there was something happening. So if water gets in there, and especially if it causes debonding, because this is supposed to be bonded, your strength is derived from making this an integral pavement of bonding the concrete with the asphalt. So you do depend on the asphalt to some degree below there. But anyway, if the concrete's debonding, then you definitely have a greater likelihood of having some cracking and some distress issues there. Ideally, this is what you'd like to see. And I was almost surprised. I took this, and this was at a joint location. So if you're going to have any stripping, any debonding between the two lifts, between the concrete and asphalt, typically it's going to be somewhere under the joint. In this case here, it was still bonded perfectly after about 18 years. Also, I've seen for the thinner concrete overlays, when you have a problem, it's usually going to be on the perimeter or at the transition. And there's probably a few different reasons for that happening. Sometimes you try thinning it up, which is a mistake, as you get to, say, a butt mill transition to tie into the existing pavement. Sometimes just the existing pavement itself that you're tying to isn't very good, and so traffic tends to put more pressure on the concrete overlay slabs. Again, water infiltrating at that joint there between the two. But anyway, this side of the intersection, though, is doing well. The other side, though, wasn't. And a probable cause is the fact that we actually, I don't know why they did this, but we actually had an inverted crown here. They slipped the turn radius here in two passes. And instead of creating a positive crown, they actually created a negative crown. So we had water seeping or flowing from either side towards the middle. It got into that joint, in the construction joint between the two passes, and that's where we had some deterioration of the slab. So not a big surprise that we had to do a significant patch here. But anyway, overall, for this 6,000 feet of a bonded concrete overlay and asphalt, this was the progression of distress starting back in when they did the first survey in April '99. And then from our last fairly thorough survey that was done as part of the research effort this year, the percent of cracked slabs, cracked and patched slabs. So anyway, any slab that had something happening to it or had been replaced already is included in this number, is at 3.5%. After a 22-year period for 4-inch bonded concrete overlay on asphalt to be performing this well with, again, as I said, a somewhat significant number of trucks, I'm really happy with this. I think it's really done a great job. And this is why we would still consider to use bonded concrete overlays in the future on asphalt, because they have been successful. Just to show you typically what you would expect, if you're doing the 6x6 panels, because the wheel paths do run somewhat in the middle of those, you typically have longitudinal cracking. That's usually your failure mechanism. For the 4x4 panels, the wheel paths are a little closer to the joints between each pair of those panels, and so you tend to have kind of a circular crack. And it usually starts as a one corner crack and then slowly work its way around till it hits all four corners of that. Okay, the next project I'm going to talk about is Route D. This was the South Kansas City area. This is kind of a bedroom community route for people that work in Kansas City. So not a lot of trucks, somewhat significant overall traffic, but only about 5% trucks. So it's not heavily loaded, but it still does get some. So you can't not consider that point in your design. The existing concrete was 8 inches jointed plain. I think it was jointed plain. I don't believe there would have been a mesh in 30-foot joints, and 1-inch dowels. Now, at only 22 years old in age, it was really badly deteriorated by decracking. And just to provide some background information, with the exception of a granite outcropping in southeast Missouri, Missouri is basically a limestone state. So, and we have some really good limestone aggregate, and we have some bad limestone aggregate. And the bad limestone aggregate tends to be in the northwest part of the state, also encompassing the Kansas City area. So this has been kind of a thorn in our side over the decades. Anyway, that was the problem here, and he had about 25% of the area, if we had done full depth repairs on this, would have had to have been replaced. And by this next picture, you know that I wasn't lying about the 25%. It really was that bad. In fact, in hindsight, you look at this and you kind of are surprised that it was even open to traffic, really. So very, very bad condition. And when we proposed doing a concrete overlay on this, I was actually a little concerned because we were going to try to get by with 5 inches. I would have preferred 6 inches. And with the condition of those joints, and we're not trying to purposely miss joints either when we're doing that. First of all, I think it's a fool's errand because you're going to hit them at some point. And it's just hard to try to do that when you're sawing the joints intentionally, get that cadence with the joint layout. So we didn't intend to do that. And so in 08, we constructed this. We made it basically kind of a big block design with the 6x6 panels. Again, no steel, no fibers. Now, what made this project unique was this was the first project in the country that used the geotextile for an interlayer. And this is now a very common practice across the country for states that do this. So this goes back farther than any other project that has a geotextile for the bond breaker. And just to go over what we did to prep the pavement, we weren't even real picky about what they used to, in this case, they used the grout slurry to just basically fill in the old patches that were there at the joints, at the decracked joints. We didn't really care what they used. They could have used as low strength of material as they wanted to. All we cared about was just having a flat surface so the concrete overlay wouldn't key into any depressions in the old pavement. And this is just showing placing the fabric. It came in, I think, 14 or 15 foot rolls. The specification that's out there for geotextiles, which is everyone's using more or less the same specification, but it has guidance for the amount of overlap you can have, and also making sure you don't have, you don't fold, spindle, mutilate the material. We secured these with nails and washers at the time. Since then, over the past few years, these companies have come out with an adhesive on the edges, so you don't have to nail these down anymore. I think I was always hoping that there would be an adhesive that would come out and make this process easier. So it's there. And just some pics have shown the placing and finishing. And here's a recent picture. So again, we're at 12 years of age. I think I took this right at 2 years ago. So at 10 years of age, looking good, really pretty sharp. There's a few places, though, again, where we do have some distress. Most of it, though, is at one end of the project. Again, as I mentioned before, the transition areas seem to be the delicate areas for thin concrete overlays, and there was no exception here. That was a problem. Possibly, we have some infiltration of water. There could be a nearby spring that's getting in under here. Who knows? So a few places like that. So anyway, we did a really thorough distress survey, all 998, almost 10,000 panels. And out of those, when I say failure rate, again, I want to emphasize, doesn't mean the panel necessarily has to be taken out. It means there could have been a minor small crack in it, or it could have been, complete failure where it had to be patched already. But any panels that had any kind of distress or visible distress, there are only 192, which worked out to, little less than a 2% failure rate. So for a 5-inch overlay, after 10 years, 2% failure rate, or crack patch rate, if you want to call it that, I would take that. I think that's pretty good performance. And the IRI itself, and you'll notice too with smaller panels, the IRI is going to tend to get a little higher, although 88 is still perfectly acceptable, I think, for this pavement. I mean, that's still a relatively smooth ride, but in particular for the bonded concrete overlays on asphalt, because you're dealing with 4x4 panels, they're near intersections, you're dealing with existing profile constraints like curb and gutter, pertinences like manholes, things like that. So that's going to drive up and also when you're transitioning to intersections every, couple hundred feet or something, that drives up the IRI for the really thin stuff. Next project I want to talk about is US 61 in Jefferson County. This was a 5-inch overlay. We did it 6.5 by 6.5 because we were doing a widened slab design, 13 foot wide on either side. Now, what made this pretty interesting was the fact that we had 220 entrances to contend with in a little under 13 miles of pavement. Businesses, residents, subdivisions, not to mention the largest single kiln cement plant, Wholesome Lafarge plant that was along this road. In fact, it's kind of the reason why we did this overlay. It was because of the presence of that cement plant. And we're mostly just placing it directly on the asphalt, except where we had to do transitions to meet the grade of railroads, bridges, and adjacent really nice entrances to some subdivisions. So we would mill down the 5 to 6 inches of asphalt that were on the old concrete pavement and then basically just pour it back to grade. Here's an example of where we did mill it down. Now, we didn't go quite to concrete on everything, but the rule of thumb was if the old asphalt was scabbed on, you really couldn't easily peel it off. We just left it on. And this is a case of here we're replacing right on the existing pavement, no milling, and this was predominantly what happened. The other interesting wrinkle here was the fact that we had a traffic control plan that kind of split up the full depth. Well, we're going to allow the contractor to pave 2 lanes across in less populated areas, but then when they got into the little heavier, the denser populated areas, they would have to do 1 lane at a time. They wound up doing such a good job of with traffic control and getting people in and out of their places, like along the shoulder, that they requested and we granted their request to go ahead and slip the 2-lane wide paving all the way through. So the entire project was slipped with, slipped monolithically 2 lanes across. Another thing this is cool, something a lot of people aren't aware of. It was invented, it's called the joint former. It's basically either clamping or more typically welding on a blade onto the bottom of the slip form pan, and typically the blade would be 1/3 of the thickness of the pavement. And what it does is, as it goes through, as you're paving it, this knife basically cuts through the concrete, separates the aggregate, and then when the oscillating beam behind there crosses over it and creates a smooth finish, you don't see anything after that. What happens is, though, you create a weak plane, and then that's where your longitudinal joint forms, hopefully. And we would do it routinely, or we allowed it routinely with concrete, with full depth concrete pavement. I was a little concerned here because this was thinner concrete pavement on asphalt and didn't know how well it was going to be able to move to separate. And I was sweating bullets after 3 days because we still hadn't seen any crack. But then finally, by the 4th day, it did. So we sawed the joint between the 2 lanes, but the joint in the middle of each of those lanes, there was a knife used to form that. So there is no sawing required for 2 of the 3 longitudinal joints, which saved a lot of effort, and it creates a nice tight crack that doesn't open up too. Here's a picture from 2018. Most of it looks this good. One thing I wish in hindsight we'd done was use the stabilized shoulder. They just used aggregate, and some of it washes out. Maintenance has to keep redressing that, but that's an unrelated issue. Where we do have some issues, again, similar to the US 60 project I showed you in the turn radius, we had kind of an inverted, because there's a kind of a sweeping horizontal curve here. So you've got a slight super that's flowing towards the pavement that's tying into it, or the entrance. Well, the entrance is also sloping down too. So you can see the water stains there, and you could also see some cracking that was occurring. So that was one weak spot. Another area that was kind of a thorn in our side, and I'm showing this slide to show you the right way to do it. When you transition to a bridge with a concrete overlay, or say the end of the project, do a full depth replacement. Don't try messing with thinning the pavement down, because usually the amount of asphalt, if you're milling the existing asphalt off, usually it thins as you get to the approach slab of a bridge. And so if you're just depending on the thickness of the asphalt being removed for whatever concrete you can put down, you may not have enough. Likely you won't. So you're better off just doing a full depth replacement at those transition areas, and then tying into the regular. Here's the result of attempting this. We had thinned this down to the point that it was nearly 2 inches thick. So this is a 5-inch concrete overlay that went down 2 inches thick. Not surprisingly, we wound up with a lot of cracking at those areas. And then we had to do the full depth repairs that we should have done in the first place. Anyway, we did a real thorough, I wish we had a more recent survey, but we did one in 2016. And out of the almost 32,000 panels along this length, we had about 333 that were cracked, spalled, or had something patched, had something happening to them. And most of them were kind of concentrated in one area. And this shows you where there are just really a couple areas where you had some major spikes and a lot of failures. Usually near we had one near a railroad crossing, we had a couple at bridges, but then you can go like 2-3 miles with virtually no distress for the entire length. So overall, great project. Last one I'm going to talk about here. I'm going to have time. Okay, no rush. 8-inch unbonded overlay. This was a standard thick unbonded overlay we're doing on interstate. We put an asphalt interlayer. We did the wide slab. We didn't put dowels in. We tried this experimentally on a few projects back in 2004 or 2006 when this was constructed. And within a few years, we started seeing a lot of cracking. This is typically what we're seeing, longitudinal cracking 3 to 4 feet away from the outside joint. And again, I'm showing you the 2-foot widening. This is widening over an unstabilized base. So essentially, we kind of had a cantilevered slab. So if any trucks running along the edge put excessive stresses on that edge and wound up with cracking. There are a few reasons why we had these failures. Another one was this is in the middle of a slab and there's a punch out. I mean, a punch out like you'd see with continuously reinforced concrete pavement, which we don't build in Missouri. And it had actually dropped an inch. And I'm looking at this thinking, how is this even possible? I mean, the only way this could happen is if the asphalt interlayer is no longer there, because underneath there's concrete. Obviously, it's not going to sink into the concrete pavement. So took a core there. Yep, sure enough, the interlayer is gone. Where did it go? I have no idea. How does asphalt disappear from the middle of a slab underneath concrete? But it did. It washed out somehow. And the other issue, too, not insignificant, was the fact that even though we had an 8-inch design thickness, because we only specified exactly enough concrete for an 8-inch average across this whole project, in some places where we had to make it thicker, then we had to make it thinner somewhere else to balance the quantities. In this case here, you can see a 7-inch core for what should have been 8-inch concrete pavement. This slide is from another unrelated project. This is an unbonded overlay. It's the only time we ever did this. Actually, another guy did this I work with. And we had some cracking going on. And so he actually went out, did a survey, and was able to link the QC cores that we had with each of these sublot locations. And so he plotted the average QC core thickness versus the percentage of slabs cracked. And although it's kind of scattered, you do see a distinct trend. The thicker it is, the better the performance is going to be. So not a surprise there on that one. So in 2013, we had to do something. We did a lot of full depth repairs, a little bit of cross stitching. The interesting twist, though, was that we sawed the entire pavement into basically a big block overlay, into 6x6 or 6x8 panels. It did so well, it was actually nominated and won the National ACPA Award for in the concrete pavement restoration category in 2015. And this is a shot from a couple years ago. So this was originally a regular 15-foot joint spacing, full width slab, and now it's sawed into these quarter panels. And we just sawed the joint right down the middle between the stripes. We didn't saw it evenly across. We didn't do 7-foot and 7-foot. This way we would have, the wheels kind of evenly distributed on either side of the longitudinal sawed joint running down the middle there. And some places we did cross stitching. A few cases where we would let the cross stitch crack serve as our joint, where you can see we sawed the 4-foot inside shoulder In addition to sawing 6x6 panels, also saw the monolithic inside shoulder as well in that case. Recent smoothness numbers, all really good. This was diamond ground too after it was constructed, so it's kind of icing on the cake. You do a bunch of repairs, you want to grind it if you can, because that's really what the public's going to notice. But the average is, 40s, 50s, great numbers so far. Okay, now we have done a research investigation of all our concrete or most of our concrete overlays recently. Applied Pavement Technology did this for us. This is hot off the presses. It was just posted on our research website, and that's the link there. So feel free to download this document. Just a few quick slides. This is just showing the easels versus cumulative easels versus IRI, and it's kind of almost immune to the effect of easels as far as on the thicker unbonded overlays. You don't really see any increase over time. And you do kind of see initially, you do see higher numbers for the thinner overlays, but for the reasons I explained earlier. And this is just one more slide. This is just showing the total percentage of cracked and patched slabs for our unbonded overlays. Don't fixate too much on the type of pavement they were put on. I'm not really showing you the slide for that purpose. I'm just showing you what the actual overall quantities were. So yeah, we had a few problem areas, but for the entire family of concrete overlays we have, we're really happy with the performance. That's why we continue to do them. Some things to remember, just like you do, or a designer would do with asphalt overlays, always estimate more concrete you'll need than your design thickness, and this allows for corrections because you're not going to be paving on a perfectly smooth pavement. You're going to have to fill in some depressions in some areas. You don't want to make that up with your design thickness. You want to have extra concrete to provide it. Provide uniform support. If you're doing a widened slab, make sure it's, the widened part is actually sitting on something firm. Otherwise, you wind up in that cantilever issue that I talked about on the I-35 project. Don't compromise the minimum structural thickness. This in particular are areas of transition, like I mentioned, to bridges. Go ahead and do full depth, replacement there if you need to, which leads to the next point about full depth transitions. And this was brought out in the example about the 61 project. Allow contractor flexibility for traffic control. You can specify kind of a bare bones traffic control plan, but this is where I think contractors can be their most ingenious is with coming up with an idea that you hadn't thought of. And so don't limit them by making them stick to a traffic control plan. Listen to what they have. It could be a great value engineering idea. And also too is, this is the reason, the bugaboo that kind of limits the idea of concrete paving, especially on a 2-lane road where you're scared to have shut everything down to 1 lane of traffic, or maybe no lanes of traffic if you're trying to get people in and out along the shoulder. And yet it can be very possible in some situations. Adjust the overlay. Don't think you're always going to get a perfect 2% cross slope. And if you're trying to balance quantities and you're worried about overrunning too much on it, you can kind of ease up on that. 1.5% is probably great. It's probably a lot better than what you had there before to begin with. Method of payment. This is the fairest way of doing it. Furnishing concrete, paying for it in cubic yards. So if there are any overruns or any surface imperfections you're filling in with extra concrete, this reduces risk for the contractor. But then also you're paying for placing the concrete by the square yard. This is in fairness to the agency paying for it, in that they have a fixed unit price or in a fixed quantity here, because obviously your area is what it is, and it should be accurate in the plans. Bonded concrete overlays, don't want to waste time on this. Theoretically, I think they should work because we do it on bridge decks all the time. We're bonding concrete to concrete there. I just seem to have a harder time with concrete pavements. So our without going into any information, any detail, I'll just say performance has been mixed, and so this would probably be the last type of concrete overlay I'd venture into if you're gonna start doing it. And also, too, is what do you do when you get to need repairs? Well, this is a case. This is a 4x4 bonded concrete overlay on asphalt. Come in, you might mill down a little farther, make it thicker, and then rather than just having to resaw the original 4x4 panels, just make a big 8x8 panel in this situation here and leave it that way. If it's a thicker panel, structurally, it'll probably be fine in that situation. But replacing these panels it's not rocket science. And the last thing I want to do is put in a plug for the Concrete Pavement Tech Center, a couple documents. One, the guide to concrete overlays, which I would consider this the definitive document out there if you're going to start designing concrete overlays. And then the companion to this is the development of concrete overlay construction documents, also from the CP Tech Center, free. And this is a great tool or starting tool if you're putting together a set of plans. This gives you a lot of typical sections and quantity sheets and examples of everything you need to put together a plans package. And I'm done. So sorry, I think I ran over a little bit, but.
Thank you, John. That was excellent. Thank you for that really good insight and the guidance that you're providing here on concrete overlays. I know that we have a lot of interest out here in the West. And so your experience over that last 20 years, I mean, we can't just get that, in a year out here. So it's great to hear all the lessons that you've learned and all the things you tried and all the kind of interesting innovations that have been happening. So I appreciate all that input. Questions. We have a couple questions. Let's see. What criteria do you use to select an existing asphalt pavement for an overlay?
If it's going to be a bonded concrete overlay, well, first of all, a lot of times the reason for doing a bonded concrete overlay is you have rutting and shoving at an intersection. That's primarily where I see these placed at. And so in other words, you have a weakness in the asphalt, it's shoving, but you don't want dried, oxidized asphalt because once you mill it, it's probably going to keep raveling and it's going to be very difficult to get a bond between the concrete and the asphalt. If you're doing a thicker, unbonded concrete overlay on asphalt, then you can be less picky about bonding. I mean, by design, you don't care if it bonds to the asphalt, even though you will get some bond in a lot of places, but you don't depend on it for the performance of the overlay. And there you basically want a relatively smooth surface so you're not wasting too much concrete filling in ruts or depressions, and make sure that you have enough structurally. The rule of thumb is you want at least 3 inches of asphalt on top of whatever type of base you have. Preferably a little thicker than that, but you're not overly concerned about bonding the concrete to the asphalt in that situation.
Right. Great. Second question here. Do you expect to have much longer traffic delay through intersections than asphalt construction? And if so, how do you deal with the delays?
We have done some of our bonded concrete overlay intersections over a single weekend, and you can come up with a traffic control plan to either do it in quadrants or maybe a half of the intersection at a time. Do it at night. Use some type of high early strength mix. But again, this is something that I think is kind of a red herring as far as scaring people away from trying it, because you can do it. We've done it. Other states have done it. You can construct a bonded concrete overlay in a relatively short period of time. For your thicker major overlays you're putting on, say, interstate or something, well, you have the same situation. You're either shifting traffic over onto the shoulder or doing lane head-to-head traffic in the other direction, something like that. But I mean, it's just, it can be done.
Right. Well, that looks like all the questions. So I'm going to thank you again for your time and insight and let you roll on. And we're going to, I want to thank the presenters for the pavement section here, the session this morning. Thanks to all the presenters for the time that they and their contributions to helping us out here. And I'm going to share one screen as we move into lunch. and we